When we talk about mixtures, the Earth's atmosphere in the troposphere, and we'll talk about what that means in just a minute, but it contains nitrogen at 78%, oxygen at 21%, and then other trace gases at 1%. And these could include things like CO2, argon, a little bit of carbon monoxide. So would this be a mixture or a pure substance? Well, remember, nitrogen is N2, oxygen is O2. Well, this would be a mixture because it contains multiple different molecules and compounds. Would it be homogeneous or heterogeneous? Well, the air that we breathe is a homogeneous mixture. It is evenly mixed throughout the atmosphere, which is good for us because we wouldn't want to go into a place that was low in oxygen because it wouldn't work so well for us. So nitrogen is an inert gas. It means it doesn't react with other substances very easily. So most of our troposphere is inert. There's a small 21% of it is what we breathe. It carries oxygen to our cells, and then even smaller amount is trace gases. Pause the video and try to draw a submicroscopic view of air. You can use argon and carbon dioxide as the trace gases. So the vast majority is going to be nitrogen. Nitrogen is usually represented in blue. Oops, those should be touching. Okay. Some of it is oxygen. And then the rest is a mixture of carbon dioxide, argon, and carbon monoxide. Just for our example, I'm going to draw one carbon dioxide molecule. So it would be about 70%, or 7 molecules out of 10 would be nitrogen, 2 would be oxygen, and 1 would be our other trace gases. So what are the different layers of the Earth's atmosphere? Well, we have the exosphere that is the highest level. You can think about it like you're exiting the Earth's atmosphere. It's where it merges with outer space. The thermosphere is just a little bit below that. So about 85 kilometers to 690 kilometers above the Earth's surface is the thermosphere. And this is where the space shuttle flies. This is where the Aurora Borealis occurs, the northern lights. The mesosphere is where meteors burn up if meteors enter into our atmosphere. The stratosphere is where our ozone layer is, and this is from about 20 kilometers to 50 kilometers above the Earth's surface. And the ozone layer is what helps protect us from ultraviolet light. Troposphere is where it contains enough oxygen for life to occur. So for people, for animals, and to live. Now, as we travel from the Earth's surface out towards the exosphere, the density of air increases or decreases. So near the Earth, the air is more dense. As we travel out, the air is less dense. This is why planes need to be pressurized so that there's enough air in them for you to breathe. If you were outside of the airplane, it would be very difficult to breathe because there wouldn't be enough oxygen molecules around. So atmospheric pressure at sea level is 14.7 pounds per square inch. There's 14 pounds of pressure, 14 pounds of air pushing down on you from the atmosphere per square inch. But we're quite used to this, and so we don't even notice that there's this much pressure. If we were up in an airplane, there's less than 4 pounds per square inch. And so this image represents this by showing the molecules as more dense. There's more in the same area close to Earth. There's much less as we move out towards outer space. Remember that density, when we're talking about density, is the mass divided by the volume. So there's more mass of air near the Earth's surface in the same volume. So the Aurora Borealis, also known as the Northern Lights, this happens in the thermosphere. The reason that it happens is that we have our nucleus of the atom, and there's electrons, like in our Bohr model of the atom. There's electrons that get excited from a lower energy state into a higher orbital. When that higher orbital, when it falls back down, it gives off light. And so we see that light getting released as that electron falls back to a lower orbital. And this happens because of radiation that collides with the oxygen and nitrogen in the thermosphere's layer of the atmosphere. The ozone layer is there to protect us, happens in the stratospheric layer of the atmosphere, and this protects us from harmful UV light. Ozone is 3 oxygens attached to each other, and it absorbs most of our ultraviolet radiation into the bonds that hold the 3 oxygens together. So UVA, that is the longest wavelength, it's the lowest energy, it causes the least amount of damage, so its wavelength is longer. And we measure wavelength from the crest of one wave to the crest of the other. UVB is a mid-length, and so the ozone layer filters out more of the UVB. It gives us a middle amount of damage, and it has a little shorter wavelength than A did. And C is the longest, most damaging, but the ozone layer filters out nearly all of the UVC. So if you've ever been buying sunscreen, you may notice that they don't protect against C, and that's because they don't have to. The ozone takes care of that. Most of the protection in sunscreen is from UVB and UVA rays. So the blue on this image is the least amount of ozone, and so you may have heard of ozone depletion, and you'll notice that this is older data. So back from 2003 is where this data starts. 2015 is the end, and the lighter blue is showing the least amount of ozone. So we had a hole over the Arctic, the Antarctic, and the ozone is being is healing itself because there's been bans on chemicals that are harmful to the ozone layer. So chlorofluorocarbons, or CFCs, those can break down the bonds between the 3 oxygen atoms and deplete our ozone layer. By banning those chlorofluorocarbons, our ozone has increased in amount and increased the protection that we have in our ozone layer. Ozone, when it's in the ozone layer, is good for us. So when it's in the stratospheric layer, that we want. That is good, because that helps protect us from our ultraviolet rays. When we have ozone down in the tropospheric level, that is from pollution. So ozone down where we breathe is bad. It's a form of pollution. It comes from nitrogen and oxygen containing compounds, sometimes called NOx, because the amount of oxygen can vary, so it could be 2 oxygens or 3 oxygens. And volatile organic compounds, they also contribute into the pollution in our atmosphere, and when we combine those, it starts to form ozone down in our tropospheric layer, and it's considered a pollutant.